Hello, welcome to lesson 42. So yes, this is actually lesson 42, where we will cover section 6.2, which is all about model selection. So you are encouraged to read pages 266 to 271 in the textbook. All right. The best model is not always the most complicated. Sometimes including variables that are not evidently important can actually reduce the accuracy of predictions. However, it is not always clear when a variable should or should not be included in the final model, so a strategy needs to be developed that will help us eliminate from the model variables that are less important. The model that includes all available explanatory variables is often referred to as the full model. So this is basically where we just throw everything in. Our goal is to assess whether the full model is the best model. If it isn't, we want to identify a smaller model that is preferable. The table below provides a summary of the regression output for the full model for the Mario Kart auction data. The last column of the table lists the p-values that can be used to assess hypotheses of the following form. So H0 is so every beta equals 0, and the alternative says that at least one of the betas is not equal to 0. So assuming the other explanatory variables are held constant in the model. So these p-values right here that are above 0.05, these are what we would say have low significance. So this would be stock photo and the duration. Here's example 1. The coefficient of condition new has a test statistic of t equals 4.88 and a p-value for its corresponding hypotheses, where beta 1 is equal to 0 is the null hypothesis and the alternative is beta 1 is not equal to 0. So the p-value is about 0 for that. How can this be interpreted? Well, it means that having a new condition does affect the price, and it is significant to the model. Here's example 2. Identify the p-values for each variable in the model. Is there strong evidence supporting the connection of these variables with the total price of the model? Well, the p-values that are less than 0.05 are significant, and the ones that are greater than 0.05 are not significant. There is not statistically significant evidence that either stock photo or duration variables contribute meaningfully to the model. Next, we consider the common strategies for pruning such variables from a model. First one is called backward elimination. So two common strategies for adding or removing variables in a multiple regression model are called backward elimination and forward selection. These techniques are often referred to as stepwise model selection strategies because they add or delete one variable at a time as they step through candidate predictors. The backward elimination strategy starts with the model that includes all potential predictor variables. Variables are eliminated one at a time from the model until only variables with statistically significant p-values remain. The strategy within each elimination step is to drop the variable with the largest p-value, refit the model, and reassess the inclusion of all variables. Here's example 3. Results corresponding to the full model for the Mario Kart data are shown below. How should we proceed under the backward elimination strategy? Well, we would take the variable with the largest p-value, and we would eliminate it. So the variable duration has been removed and a new model fitted. Now how should we proceed under the backward elimination strategy? So now we see that the next largest p-value that's bigger than 0.05 is the stock photo, so now we're going to eliminate that one. Oops. And you might also notice that our degrees of freedom increased by 1 because we had decreased our number of groups by 1. Notice that the p-value for the stock photo changed a little from the full model. So in the full model it was 0.3085 to the model that did not include the duration variable. So now it's 0.2747. It is common for p-values of one variable to change due to collinearity after eliminating a different variable. This fluctuation emphasizes the importance of refitting a model after each variable elimination step. The p-values tend to change dramatically when the eliminated variable is highly correlated with another variable in the model. So in other words, we don't want to just eliminate all the variables that have high p-values at once because of this collinearity issue. The latest model we see that the two remaining predictors have statistically significant coefficients with p-values of about 0. Since there are no variables remaining that could be eliminated from the model, we stop. So this means that all of these variables, these two variables, are important because their p-values are about 0. This is considered the best model. So I'll write that down. Here's example 5. Write out our final model for predicting the total auction price. So the prediction price equals 36.78 plus 5.58 times the condition new variable plus 7.23 times the wheels variable. This is coming from the first column of the table. Part B, what is the expected price for a new Mario Kart game that included 2 wheels? So the expected price equals 36.78 plus 5.58 times 1 because it's new, plus 7.23 times 2 because there's 2 wheels. So this equals $56.82. Part C. What is the expected price for a used Mario Kart game that did not include any wheels? So the expected price would equal 36.78 plus 5.58 times 0 because it's used, plus 7.23 times 0 because of no wheels. So this would equal $36.78.